Okay, the timer is starting. Yeah, um, thank you so much. Hello and welcome. My name is Andy. I am a IT architect, Linux and Kubernetes at MTU. MTU as a company, what are we doing? We are doing aircraft engines, and so IT is not our main product, but an enabler. It's the digital backbone for all of our business units. And so what are we doing with Linux and Kubernetes? When it comes to Linux, we have high performance computing, virtual desktop infrastructure. When it comes to Kubernetes, we are hosting our business applications there. And yeah, so we call our Kubernetes platform the cloud native platform. And yeah, in recent years, this platform was consumed quite heavily, more and more users, more and more feature requests. And yeah, in the end, we became the victim of our own success and in the end a bottleneck. And the talk today is about how did we solve this issue about being a bottleneck instead of an enabler. So I will talk about infrastructure as code, GitOps, and hyper-converged infrastructure. Before I jump into the topic, I would like to share a couple of slides about MTU. MTU reshaped the future of aviation. We are flying high from one record year to another. There are a couple of um, numbers here. And yeah, so we have quite a balanced portfolio. So we are one company, but we have different use cases. So we call it the OEM and the MRO. So with OEM, we mean we are designing and manufacturing the aircraft engines. And with MRO, we mean, yeah, maintain, repair, overhaul. So after some thousands of flight hours, we are fixing the aircraft engines. And so we are doing both. And yeah, so it is a high-tech topic that is not so easily copied by Chinese companies. And so we are, at least for the next 10 years, I guess, saved from something like a China shock that we see right now in German media. So yeah, I said balanced portfolio, MRO and producing the aircraft engines, but also having civil aircraft engines and military aircraft engines under one company. And we are a global company, which basically means we are doing one global IT for the entire world, where we have locations of MTU. And so whatever we do in the central IT influences MTU worldwide. And yeah, the numbers, we had a goal for 25. It was 2518, so 2518. We succeeded with that. But now let's come back to IT and the topic I would like to present today. And it is a topic about paradise and hell. So on that slide, I called it the two-speed problem. So on the one hand, we had the fast lane for our users. So we were using, or we are using multi-cluster manager, Rancher. We are using Kubernetes, GitOps principle, and our users can consume the Kubernetes API and the resources in an on-demand self-service manner. So this is really in the core, in the DNA of Kubernetes. Obviously, military sector, so obviously within resource quotas and security policies. And so, yeah, before there were a lot of tickets for our users if they wanted to have a server, storage, and so on. And now, yeah, it's just one request. They request a Kubernetes namespace, and then they can consume all the infrastructure on demand, self-service, and they can deploy and manage their applications by themselves. And then we come to the slow lane. Because when we want to create new Kubernetes clusters, then yeah, we are dependent from a lot of IT silos, and provisioning a new Kubernetes cluster was really a pain. Lots of tickets, lots of delay, multiple weeks of friction. And yeah, great user experience and terrible admin experience. And yeah, coming back, we could say, okay, then we only have one Kubernetes cluster and all users are in one Kubernetes cluster. This would be a nice solution. And for Kubernetes agnostic applications, this is the right solution, because a Kubernetes agnostic application does not know that it is living in Kubernetes. It does not want to talk to Kubernetes. It does not need authentication or authorization within Kubernetes, and it does not want to speak to Kubernetes. So for Kubernetes agnostic applications, we can just run them in different namespaces, harden these namespaces, network policies, pod security policies, you name it. And then we have multi-tenant Kubernetes clusters. But yeah, there are not only use cases with these Kubernetes agnostic applications, there are also these Kubernetes native applications. They know that they are running inside of Kubernetes. They want to talk to Kubernetes, and to harden Kubernetes in a way that they are not interfering with each other is quite difficult. Yeah, just take the operator pattern, deploying an operator or deploying Kubeflow, for example, or other applications inside of Kubernetes. They expect to be to have cluster-wide access and interact with the Kubernetes API and create cluster-wide resources. And so they clash in this concept where we only have one Kubernetes cluster. So there are more and more use cases in the last couple of years where we have these Kubernetes native applications, and there was a need of deploying new Kubernetes clusters easily and fast. And so the first option I mentioned already, shared clusters, namespace isolation, high density, a lot of advantages, high density, low infra, overhead, but as I mentioned, not applicable for all the use cases. Interesting topics, a lot of nice open source tools. I mentioned here one, vCluster, better isolation, only little resource overhead, but yeah, some additional complexity that was where we were scratching our heads. And then the topic of cluster as a service. We are providing a full-blown cluster for our users, maximum isolation, all use cases that can be deployed in Kubernetes can be run with this principle. But as I mentioned in the slide before, massive operational overhead. It took us days and weeks to create new Kubernetes clusters. And yeah, you can always think of a scale. On the one side, we have cluster as a service with maximum isolation, less density, and namespace as a service with little isolation and maximum density. And there are some open source tools that are in the middle. So yeah, let me give you a bit more explanation and insights of this this issue that we had with creating new Kubernetes clusters. What was it really? Yeah, we had to create VMs. That was one ticket. We had to create give them IPs, then load balancer endpoints, DNS, security topics like certificates, and so on. So dozens of tickets. Each ticket took multiple days, and in the end, multiple weeks of friction. And yeah, this is the opposite of DevOps. And yeah, we have an ID, we want something, a new Kubernetes cluster, and bloop, 15 minutes later, we should have a Kubernetes cluster. But yeah, we were dying the death by 1,000 tickets. So what was our idea? We created this paradise for our users when they are consuming namespace as a service. They were consuming the Kubernetes API, and so our idea was, why aren't we our own customer basically for the concept of cluster as a service? In this slide, I mentioned the word SUSE a lot because we are using the SUSE products, but actually you can use Red Hat, Kubernetes, or CNCF open source products. It's just that we at MTU, we are using the SUSE stack. So we are using Rancher, the Rancher Kubernetes Engine 2 and SUSE Linux. And for us, the big moment was that, that we want to manage the underlying infrastructure with Kubernetes itself. And so this is the field of Container-VM-convergence and hyper-converged infrastructure. Again, a lot of SUSE, but you can use any vendor you want. And yeah, the new workflow was then VMs provisioned by SUSE virtualization and Rancher, the IP topic, the load balancer topic, DNS topic, security topics, and so on, all automated within this new framework. Best practices. Here, the topic of eat your own dog food. For me, it was always important when I introduced Kubernetes into a company to give the users best practices, and GitOps is for many, many years a best practice. And so why should only the application owners and the application managers use GitOps? the recommendation definitely is to use GitOps also for infrastructure. And so infrastructure as code, we define everything as code, VM templates, network, cluster definitions, DNS records, and so on. Yeah, if it's not in Git, it doesn't exist. So earlier we had a very nice talk about GitOps, and I liked this idea of GitOps not being the single source of truth, but the single source of intent. And the vision, the zero ticket workflow for our admins. So yeah, what did we gain by this approach? The old way, these 2 to 3 weeks of delay, and now the new way, a Git push for ICE principle, Git merge, a CI pipeline running, and provisioning by Ranger, Harvester, um, and a GitOps operator. And in the end, yeah, as we are we are not only doing civil aircraft engines, but also the military ones. So we are in the defense sector. So BSI Grundschutz is important for us to be compliant here. So in the end, a fully compliant, secure Kubernetes cluster provisioned and registered in Rancher, ready for workloads within 15 minutes, all from a single Git merge. So yeah, what did we gain? Basically, I mentioned now on this slide a lot of things, but in the end, it is all about cost efficiency. When we see the topic of the speed gain from multiple weeks to 15 minutes, when it comes to that these clusters are all identical and born compliant, and reducing the manual steps and no more manual configuration drift. The topic of audit-ready security. We have everything in Git, so everything is logged. The Ranger Kubernetes engine is hardened out of the box. One huge benefit, the topic that we can collapse our silos. And why do we need 2 teams? One team for VMs, one team for containers. We can combine the teams and have a huge gain in efficiency here. And yeah, we are really, really happy with Kubernetes and how solid it is, the self-healing capabilities of Kubernetes. Yeah, what is next for us? The last couple of years, it was always a challenge working with infrastructure, waiting for infrastructure, and so on. So the last couple of years, our work was really infrastructure focused. And we hope that with this new technology, we can finally be a real platform team and deliver things that our users precisely want to them, instead of managing our infrastructure, creating here a new cluster and there a new cluster and so on. So focusing on the topic of self-service for our users. Right now, they are able to consume the Kubernetes API, but yeah, this means everyone, every user, every developer, every data scientist has to learn about Kubernetes and the Kubernetes API and the ins and outs. And our hope is that in the future, we can focus on these topics to really make their lives easier. Creating golden paths, so not one standard path, but also not too many. Having most of the things built in, zero touch, when it comes to security, compliance, and observability. Yeah, and shifting our focus, as I mentioned, from provisioning to consulting, helping our users more in workshops, trainings, office hours, more documentation and templates, and being not the bottleneck anymore when it comes to provisioning infrastructure. And yeah, we are not calling it the golden path, but for us, it's the golden turbine. So yeah, let's summarize. Building on these topics. Yeah, by the way, I didn't mention the open source tools behind it. I forgot. So SUSE virtualization is a fancy name for a stack based on very nice open source tools. And the main tool behind it is Harvester, and Harvester again is based on Kubevirt, a CNCF project. Yeah, Ranger is Ranger. There are other multi-cluster management tools that you could use as well. As a GitOps operator, there is the war between the two. We are using Argo CD. And yeah, by using a stack like this, we turned ourselves from being first a bottleneck now into an enabler, and after 15 minutes, you get your Kubernetes cluster. And yeah, with that, thank you so much. I'm open for questions.
Thanks for the talk. You briefly mentioned in your talk that you also use Kubernetes in civil and military aircraft. I was wondering, did you get Kubernetes certified by the Luftfahrtbundesamt for this?
It's not inside of the engine. So Kubernetes is running in our data center, and Kubernetes is enabling our business units.
I thought it might be flying already.
This will, yeah, hopefully this will come within the next couple of years, but so far we do not have the project. No.
Okay, thank you.
You mentioned GitOps, but not the tool you used for GitOps. Did you use Ranger Fleet or did you use something different?
Yeah, this is now you talk about a pain point. So we used Fleet. We used Fleet in the past. We had some feature requests that were never implemented in a satisfying way, and so we migrated everything to Argo CD.
Hi. You show your stack here. Is it all on-prem data centers, or are you using cloud service providers?
Yes, so we did a couple of baby steps in the cloud provider, but this talk was about our Kubernetes stack on premises. And yeah, so this is a slide. Actually, I stole this from a SUSE slide deck. So we are using SUSE virtualization, SLE Micro, RKE2, and Rancher. And when it comes to storage, yeah, we have actually storage admins that are using NetApp storage. So we have always the option to use Longhorn and SUSE storage, but we right now we prefer, as we have an own team that is doing storage administration, we are using NetApp. When it comes to SUSE security, the open source tool behind this is NeuVector. We are using this. When it comes to SUSE observability, right now we have a POC, or it is much more than a POC, with the Grafana stack as an alternative. And we are very happy with the Grafana stack right now, and the early adopters as well. The app collection is very nice, where you get really clean base images. We had another talk yesterday, I think, about what it means to have clean base images versus base images from the open source projects, and that there's a huge difference in the CVEs and the criticality. So we are very happy using this SUSE app collection because they are very, very clean. No questions?